thank you, Jean-Paul, for the introduction. And yes, indeed, you raised a fair point. If I had to explain every step that's installed in a glass recycling plant, we would probably take a whole day to explain every kind of these steps that we have to put in our production process to get a material where my colleague Hans is happy with. So let's not go into that. First of all, let's say something about Malta. So we one of the leading glass recycling companies. I said not the leading, but one of the leading glass recycling companies. So we are mostly operating in the west of Europe. We have 6 plants. So we are in Holland, Belgium. We have 3 plants in France and one in Portugal. So mostly on the west part of Europe. So let's start with the first slide. We're gonna explain what a CSP, like Hans did this already. The options that we as a glass recycler have to remove I always call it CSP, so sorry for that, but the ceramics to move from the process, the consequences in our recycling facilities, and how you, the listeners, and also closing the glass loop can help us, let's say, to ease in our job and to make, of course, Hans really happy. Start with the first one. This is already explained, but I'm going to repeat myself. So CSP stands for ceramics, stones, and porcelain. Now, stones, I think at this point is not, I say, really interesting. So we're looking at ceramics and porcelain because those are the things that we have and do find in our input materials. Where does it come from? I think already explained, so maybe I'm going to repeat myself again. Household waste. So why is that? Now, you can imagine that if you are drinking a nice beer or lemonade or cola or whatever, you think, okay, this is a beverage, it's contained in a container of glass. So, yeah, really nice. I put this in the glass bin. But afterwards, you maybe have the interest in a liquor or a Geneva jar or drink, I would say. And then you think, okay, this is also a beverage, it's in kind of a bottle, so probably it goes into the same bin. Well, guess what? That's not really ideal. Why is that? Because this comes then to the glass recycling plant, and it's our job to take out all this kind of materials, which we call, of course, CSP. Also, when you look, and this is the topic of today, to the commercial sources, so the restaurants, hotels, and so on and so on and so on, I think there is the same idea. It's a beverage, it comes in a container, so it all goes into the same bin, which of course is again not ideal. And then also in the mixed waste streams, so if we do not sort and collect in the correct way, we get this kind of material in our incoming stream for the recycling. Now, it's in. We cannot do anything about that. Closing the glass loop will fix the problem. So we're going to teach everyone in all the world that they don't need to put and that can put the CSP parts in the glass. But how can you take it out when it's still in? Because we're not living in an ideal world, fortunately. So we have, let me say, automated, Jesus, and manual sorting. So that's the first and maybe an older step. And we have also what we call optical sorting, which is a more advanced technology. Let me start with the first one. You can see the picture on the right. This is actually a picture of a manual sorting where there are people standing on a belt for 8 hours trying to take out as much as they can ceramics that they see by their eyes. Now you can imagine that if you have to do this for 8 hours and approximately the material coming in is like between 20 and 50 tons an hour, and you have to pick all day all this kind of pollution, yeah, it's really not an ideal world. So you have a repetitive work where you can have injuries of doing the same movement all day. It's a safety issue because you are with your hands in really sharp glass, which, as you can imagine, isn't ideal at all. And also, it has a really limited effect on the end quality, meaning you cannot take out every piece that's in there. You can only take out the big chunks where your eye falls on what you see that you are able to pick. And of course, the ergonomics is also not ideal to do this. The second one and this is common for, say, for the glass industry, is what we call optical sorting. Now you have these in all kind of different shapes and brands, but basically it's all the same technology. So let me explain something. So you have a light source on one part and you have a camera on the other part. So when an object falls through this machine, the light goes through the glass cullet and the camera sees the shape of the glass, even sees the color, even see if it's HR, which is heat resistant, but that's not the case in this presentation. But if a piece of ceramics fall through, there is no light transparency, meaning it's a black spot. So when that happens, the camera sends a signal to the computer, who then says to a lot of valves, and valves are something like a compressed air machine that blows away a particle, that says, okay, on this part of your line, there is a part called CSP and you have to shoot it out. Now, that worked pretty well. But to give you an idea of the amount of optical sorters that we have to put in to clean the glass so that Hans is happy with the quality that's getting into his furnace, we're talking about up to, let's say, 29, 30 of these machines installed in the production lines. Now, why is a piece of CSP bad? Because you're gonna lose a lot of yield. And what is yield? Meaning you have 100% of input material in your line, and you only get the material out that you can sell to the glass industry, and you have to take away all the shootouts of these machines. So the more CSP we have in our input product, the less yield and also the less profitability we have with the recycling plants. Now, why is that? Because if you look at the rejection and the shootout of CSP, you have to imagine that if it sees one part which is black and it needs to be shooten out, you don't want to shoot with compressed air only, let's say, 1 millisecond, because then you have the chance that you miss this piece. So what do? You put on the valve, let's say, 20 or 30 milliseconds, meaning you shoot in a way more range to get this piece of CSP out. What happens when you do that? First of all, you're pretty sure that the piece is out, but you also shoot glass, which is not so good because that again is a yield loss. Now, with all this kind of streams that you're shooting out, you have to invest again in what we call a CSP recovery line. So meaning this material that's been shooting out still contains like up to 90 to 95% of glass, which you want to send to Hans and not, let's say, put on a landfill. So then they have to invest in what we call a CSP line, and it retrieves again the glass from the shootout of your main line. Excuse me. If you then look into the, let's say, quality check of our incoming streams, and this is, I kind of keep it on the low level, but an average of 10 to 20 kilograms of input of ceramics in 1 ton of glass of incoming material is really still on the low level, but this is where we face with every day. So there is still a lot of this material and a lot of benefit to gain from this. We already saw this in the previous presentation. So before we can deliver even one lot of, let's say, 1,000 tons of glass to the glass furnace, there is a check. And the check, if it passes, you can deliver. Is it not approved, then you can't deliver. So in 1 ton of glass, and 1 ton of glass is kind of a big heap, I would say, you can only have maximum of 20 to 25 grams. Now, this number every year gets smaller and smaller and smaller because you heard it already, there is a risk at the glass furnaces. So by lowering all these numbers, we have to invest more and more and more into machineries. Why is that another problem? Not only for quality, but it also reduces efficiency. So the more we shoot out this kind of material, the more glass we need to put in to feed the furnaces. So you're losing a lot of good glass in the end, and then you have to purchase more to get the same amount out of your production process. By every step that we add into the recycling process, we add, of course, extra costs. That can be capex and also opex, because you need to invest in machinery. but also they cost, let's say, maintenance, spare parts, and so on and so on. And also, in the next step where you see the environmental impact is that all these machines worked with compressed air, meaning you have compressors that deliver this. Now, one of the most energy consuming assets in these factories, beside of gas, is compressed air. So the more you shoot with these valves on this CSP parts, the more energy you consume, which of course is not good also for CO2 reduction. The next slide is how can you help us? And with you, I mean everybody listening to this and everyone where you're going to share this information with. I think first of all, individually, look at where you put your glass and where you put your ceramics. Please, you saw now two of these explanations from the glass furnace and the recyclers that you really need to separate this. When you see that other people do not follow, let's say, your example, please tell them. Say, what's the consequence? People can get hurt in the glass furnaces. You saw this picture where this piece of glass with 1200 degrees just missed an arm. You can't imagine what that happened. We don't want that at all. So follow the local guidelines. Also, something mostly when you go to a glass bin or we go to an area where there is a waste collection, there is some kind of pictogram where you can see, okay, what can I throw in and what can't I throw in. Please follow those guidelines. And then, last and not least, choose alternatives and not ceramics. Yeah, I always say if you have an option, always go for glass. That's always the best choice. And then maybe to end the presentation, you see below we stated Malta makes glass endless. And that's true because glass is one of the few products that can be recycled over and over and over again. But it would be a little bit, no, it would be way more easy if everyone helps us a little bit and don't use ceramics, let's say, in the glass bins. That would make our life easier.